Okay, so we're all set. I got my wire pulled and all secured. So two there, two there, two there, and one there. So I'm going to start with this wall here, which is its own circuit. We're going to have an outlet here, and a switch here. This switch is going to control the lights that I'm going to put up. There's going to be an 8-foot, sorry about the camera, an 8-foot light here, and this light is going to be put above my head. Now, more than likely I'm going to end up changing this out and putting the 2 gang box in there and 2 switches, 1 for each light. And I just haven't figured out the easiest way to get the wire from here to the light that's behind me. I kind of want to keep the big 8-foot light off of the original circuit that was down here for the lights, just because I traced that all back and I figured out that that light, the lights down here actually, the switched lights, are hooked into pretty much every light, all the permanent lights in my house except for the one in my dining room. So I want to keep as much amperage off of that as possible. Oh, also it does, I have outlets on the walls down here on the other side. It does those too. So I want to keep as much amperage off of that as possible, even though it's the 8-foot fixture only draws 2 amps. I still want to keep as much off of that circuit as possible. So that's going to come off of this 20 amp circuit I'm putting in this wall. So anyway, so we're going to start out wiring this sucker up. Put this in my tripod here. Okay, so I got the other walls all set. I didn't want to do a video of that just because it's kind of awkward with being able to see through the wall there. So nice solid surface here. You can see a lot better. So just a quick point. If you need to wire out anything together, there are plenty of different brands out there. I'm pretty sure Home Depot and Lowe's and big box stores and stuff, I'm pretty sure those sell Ideal, Ideal brand. And I don't like them. It's just a personal thing. I'm more partial to Buchanan's, and I use almost exclusively the red ones, except for at work. I use the orange ones for bell wire and certain applications and stuff. But these, I don't know, these seem to be a little bit more robust to me. Plus, they have the little twisty wings. Not that it makes a difference, but also any wire nut that you get will usually have a listing of all the different wire combinations it does and minimum and maximum sizes. So for this red here, we have a minimum of 2 18-gauge wires, a maximum of 5 12-gauge wires. I just like I said, like these a lot more. You can go crazy with the wire nuts and get those rubber coated ones. They're like $30 for like 25. I think these are like 12 or 15 bucks for a package of 100 that I get at my electrical supply. So anyway, you want a minimum of 6 inches of wire sticking out of your box for connections, and then you tuck the wires back in. That's one of the biggest things I see people do, is cut them like super short. You can't do that because you need to be able to work on the outlets, put all your screws in, and then sit it all back in there. Also, if you'll notice as I go along here, this is a 20 amp circuit. My GFI is 20 amps, which you can see by this sideways prong. If you have an outlet or a plug that has 1 vertical prong, 1 sideways prong, that'll be your 115 volt 20 amp outlet. Usually I think the 208's two horizontal blades, or the opposite of this. I can't remember off the top of my head. Also, so you notice that this is a 20 amp plug, which is what I'm going to be putting in, what all the other ones are going to be ganged off of. And you notice all the other ones I put in are going to be 15 amp outlets, because in all honesty I don't have anything that requires 20 amps to run. 15 amp outlets can go on a 20 amp circuit, but obviously you can't put a 20 amp outlet on a 15 amp circuit. So the only reason why I'm putting the GFI. Not that it really makes a difference. You can still use a 15 amp GFI, but it is a GFI. So I like to rate the GFIs themselves to the actual circuit. The other thing too is I've gotten into arguments with people about this. Orientation of your outlet doesn't matter. Dropping it sometimes does. Orientation of your outlet doesn't matter. They don't have to be installed upside down. All right? The reason why people install it upside down is partially because the ground lugs on the top, so it makes it easier to get at. Also, the theory behind it is when you go to unplug something and pull the plug out, 90% of your time your thumb's going to be on the top, and that tends to overhang your bottom. Just go to your plug right now and try to pull it out. You'll see that your hand ends up like this. So if you slip behind, if it's this way and you happen to slip with your thumb, you're going to arc yourself out through your thumb between your power leg and your neutral. Right there. It's all, if it's this way, if your thumb slips in behind, all you're going to do is touch the ground. Nothing's going to happen to you. So like I said, it doesn't really matter which way they go. Personally, I prefer just regular way. That's the way I'm going to put them in. Also, they do make the outlets. Obviously, here's for the GFI, and here is for a regular outlet. You notice that there are 3 holes on here, and there are no tabs, no gang tabs in the box. Before, you used to be able to just take this one screw here and screw that sucker right into the middle of your outlet there, and then that's it. Can't do that anymore. If it has 3 holes like this, you have to use all 3 holes to hold your outlet in place. All these come with screws and nuts. You got to take these out, these mounting screws out, use a screw and a nut backing into this hole. Also, if you're putting it in a box instead of on a regular outlet on your wall or something, it doesn't matter. But when you put it in a box with a faceplate like this, these little ears have to come off. They don't fit. So you got to snap those off to get them in there. Also, you can do this multiple ways. This is only one way that I'm going to do it. When these are in here like this, power is going to come to the top of the GFI here, which usually says line, or the load side here is usually taped off. And obviously white goes on silver screw, black goes on gold screw, your ground hangs out down here. From here, we're just going to have 2 wires coming off the back of this here, where it says load, and that's going to feed this outlet. Then these other 2 screws here on this outlet, so you can see there are 2 on each side. One set of wires from here are going to go to here, and then the other set is going to be this wire, which is going out to the other plugs. So basically this GFI will be hooked into all the other outlets I put in. Also, when I do the ground, you notice I'm going to twist them all together, and I'm going to loop it around this ground screw in here. This ground screw is going to get tightened, but I'm also going to leave one really long, and that's also going to hook onto the screw. So I'm going to ground the device and the box. The reason why I like grounding both is because if you ground just the device or just the box, a lot of times these screws, people pulling things in and out, moving things around, can get loose. And your only attachment to this box is this face here. So this way here, I have an attachment to the box itself and an attachment to the device. If this ever gets loose for any reason, I still have a ground to my device. So let's get to that. I'm going to leave these long because I'm going to leave one of the ground screws really long so I can hook it and pull them through. This here, like I've said before, you have multiple ways of stripping it. They make the purpose-built strippers that look like the regular wire strippers, but like the plier type ones, and you just pinch it and pull. They work. Don't get me wrong, they work great, but it's a single-use tool, and it'll probably run you, like I said, anywhere from 18 to 25 bucks. This, also a single-use tool, $2. So just grab the tip, give yourself a slice. Now I only slice a little bit of it. If you go down and pull, you have a chance of nicking one of the wires. If you do it while it's out here and you nick one of the wires, you're all set. You can just cut back beyond that nick. But if you nick it up here, you're screwed. So let's get those and then just peel it right back into the box. And leave yourself about a 1/4 inch or so of the jacket inside the box. That's mainly just so an inspector can come and look and see that the jacket is still intact if you don't have a cable clamp at the top, and also tell the gauge of the wire. It's nothing to do with the operation of the actual electrical circuit or anything like that, or protection. Okay, so we'll get the jacket out the way. This paper out the way. Okay, so there's our power wires, 6 to 8 inches. I'll give us about to there. Also, whoop, missed one. Also, you can buy the wire strippers to strip these. Personally, I don't like them. I only use them for crimping on solderless connectors. Whoops. Sorry about that. Didn't mean to hit you. Let me zoom in here. So I always just use either pair of Dykes or Lineman's. All you gotta do is just very, very lightly hold down on the handle, score it, and pull. And there you go. You're stripped. Another thing too. If you are using wire nuts and you got to loop the wires together, it's good practice. In my opinion, a wire nut is not a tool, but people use it as a tool. A wire nut is not meant to spin these wires and wrap them around each other. In my mind, the only thing a wire nut is there to do is to hold those wires together once they're twisted together and to insulate the ends. If you're going to put two wires together and need a wire nut, get a pair of pliers and Lineman's and spin them. Spin them together nice and tight, clip the tip off so they're nice and even, put your wire nut on, and electrical tape it. Do you have to do that? No, but it's very good practice to do. Okay, so you want to ground. Alright, I just had to go get my Lineman's. Alright, so I'm going to wrap this ground here around that screw. If you put anything around the screw, loop goes clockwise, so when you tighten it, it sucks it in. Tighten that screw down, and then this other ground here, we'll tuck back there, put them together, grab about 5 inches in or so, and we just start to twist. Now they also make pliers that are meant to twist. You clamp them, it has a little kind of like bearing the handle thing, so you can put your hand on it and just twist it. Regular pair of Lineman's does the same thing. No special tools required. Okay, twist those together nice and tight so they basically become one wire. Now you notice, clipped one of them back, so there's only one strand there. That's what's going to be going to my device. And that's my cat. What? Oh. She knocked her mousey down the stairs. Hang on one second. Alright, so just getting ready to pop our plug in place. I got a couple of wires already cut to go from this to the other one. Now just a quick point about these, or any plug. On the back here, if you notice, you have, where is this one? Right here. Actually, is it underneath here all the way or not? So, if you notice on the back of any outlet here, is usually a strip gauge. That'll tell you how deep to cut the wire if you use the stabs. Now, let me just show you something different about a couple of different outlets. This one isn't so bad. If you notice on the back here, here's your screw, and right here is a metal plate. That plate is underneath the screw, and if you were to put the wire in there, like that, and tighten the screw, it'll clamp it right onto that plate. That isn't bad. I personally prefer the loop around the screw method. I think it holds more. This is acceptable. This is not bad. You can still use that. What you don't want to do is, here's another example of a different outlet, is to use the friction stabs. The screws don't matter. There's no plate here. All you do is take this, and it's like a little spring-loaded tab in there. And all you do is push it in, and then that holds the wire. And it holds it, but the only problem is, guess what? What can you do with it? You can do this. Over time, that's going to heat up. That wire is going to loosen. There's no doubt about it. There's just no way. So, personally for me, I always loop around the screw. Also, just another little fact that a lot of people don't realize. This is a regular outlet, okay? So, I don't know if any of you guys have ever been in a house where, say, this outlet's constant all the time, and this outlet is controlled by a switch. That's not two circuits. What that is two separate wires going to the switch. If you notice, there are 4 screws, one for each side of this plug here. In here is a little bar that goes from this screw over to the other. If you wanted to separate and unjoin these 2 outlets, the top and the bottom, you snap that tab off right there. And then you could have one wire up top and one wire for on the bottom. Like I said, usually you see that in as a wall switch will control the top outlet, and the bottom outlet will be on all the time. Okay, so anyway, I'm going to take this. These wires here are going to be our load wires from this to our other outlet. So let's take a screwdriver, and I've actually kind of been using that Milwaukee with that funky tip. It works pretty good, I do have to say. Like in one of the comments of that video, like somebody said, good concept, and it, you know, it doesn't slip off the screw. I do like it, but it's never going to replace a standard screwdriver. It's just no way. So you get that in there, clockwise around the screw, and some outlets, not all, have a little tab to put the heel of the wire in. So when you tighten it, it holds. White wire on the silver screw. Black wire, gold screw. And actually on this screwdriver, this little hole thing here, for the loops is pretty much useless. I've just been using a pair of needle nose. Again, bend our hooks on our wires that we have up here. It's a little too long. And you know, when you do this for a while, you'll get a feel for how far back you have to strip them. Okay. So. Now another good habit to get into, and there's nothing saying that you have to do it, tape up your outlets and your switches when you're done. These tabs got to get taken off. They're already scored, usually. Break them off from alignments, probably a better idea. And then our other switch, outlet, it's not a switch. So, take these. Okay. These little tabs on the top here are in my way. Let's nip those off. There we go. So this one here, okay, so we got it all connected here. You can see all the screws are in place. Now we have our main power coming in here. Here's our ground, which is looped around the lug, which is then tied in with our other ground, grounded to our device. That will ground out this entire faceplate. This other plug is bolted directly to this faceplate. This is not going to come loose, so this other outlet is grounded that way. This right here is our main neutral coming in, our main power coming into the top of the GFI. From the load side of the GFI, our neutral coming over to our secondary outlet here. From the power here to the side of our secondary outlet. And then also from those same terminals back out into the rest of our outlets. That way there, this one GFI will be controlling every successive outlet, and basically all the other ones will be hooked up pretty much the same way. There's going to be a couple in here that are only going to have one outlet in place instead of two. I planned out there's going to be a total of 6 outlets on this circuit through four boxes. So let me clip you back to the stand. I just forgot to tell you, just a quick note. These GFIs themselves usually come in the tripped state, so when you apply power to it, this red light will be on. Just press the reset button and everything should be fine. If you can't reset it, if this won't reset, more than likely you have your 2 wires on the back of here reversed. If the polarity on this is wrong, they won't work. So just be aware that the little light is right here to glow either green or red. Also, these are supposed to be tested once a month. Just go over to them and press the little test button, make sure this pops. If it doesn't pop, replace your outlet. Like I said, the only thing with ganging a bunch of these together off of one GFI is you'll have a tendency, if you have too long of a run, too many on the that one GFI, you'll kind of tend to have nuisance trips. You can do it like I'm doing it. We're running it off of GFI itself, or you can actually GFI the entire circuit from a breaker. The breaker itself will cost you about 40 bucks. The only difference of putting it in is instead of having just the power wire go to it, both the power and neutral go to it, and then you take a pigtailed neutral off the breaker and put that to your neutral bar. So I'm going to get to the rest of these, finish up the electrical down here, and hopefully pretty soon I'll actually get to move my equipment in here. It's just been a slow going process because not only have we been dealing with this here, I've been dealing with some other stuff, all kinds of other fun stuff with owning a house. So okay, all the electrical is now done. We have all our outlets in. There's one there, and the last one over there. Now that one over there, I have that light plugged into it. So now, if I hit the test button on this, that light should go out. There it is. And you can see that little green light is off. Now hit the reset button. Little green light's back on. And so is the light. I put the 8-foot light up, which is right here. I put the globe back. This outlet here is switched from upstairs. So basically I can switch that on, have that light turn on, and then I have 2 switches here. One is controlling that 8-foot light, and one is controlling this 4-foot light. This one's a T5 standard bulb, 28 watts a piece. It's T5HO, 54 watts a piece. So you can see, oh, that's the wrong light. Let's switch that one off. Turn that one on. It throws quite a bit of light. And also we have our walls up. Just have a quick first coat here on the joints, let that dry, and throw a second one over there and sand it smooth. Now, granted, hanging drywall is a bit of a skill and an art, and it's definitely a skill that I don't really have. But it's up there, looks like a wall, functions like a wall. The only real issue that I had was because this floor is so uneven. When you cut the board to a certain height, sometimes you'll hit a high spot in the floor, and when you go to push it and force it in, you'll break a bottom piece. Case in point would be like right about here. As I hit a high spot in the floor, you can see I actually broke the drywall. That's not a huge thing on the bottom because I'm going to have the 4-inch rubber strips that go along here. I haven't put up a couple of the corner beads yet because I ran out of screws. So I'm going to do that tomorrow and get that all set. So here's the door, and got it all on that little side there. I did have to cut around those 2 pipes. I had to split that into 2 pieces, so I couldn't get this one piece to fold in behind those pipes, so I had to cut a square out of it, push it in place, screw it in, and then basically patch that one section. But it's up, and the shop's pretty much together. At least all the hardware's done. Like I said, this is a lot smaller. We're working with 20 by 20, and we have those washer and dryer to contend with in the corner. I do have a sink down here now, though, which I never had in the other shop, which I definitely do like. But you know, we work with what we got. At least this one's all mine. Thanks for watching this one, and see you in the next video, and hopefully we'll have equipment in the shop.